Welcome to this first lesson on sequences. We're going to look at sequences for a few days in class, and I just want to explain sequences are an ordered system of presenting numbers. Usually you'll see them presented like this. And then you'll have ... ending it, saying that it goes on and on forever. Now the whole reason we look at sequences is we study the elements. Each of these terms is an element of the sequence. Now, why we look at these terms and we study how to get from here to here. Let's say we have 3, 5, 7. You might already be saying, oh, I know how that works. You're just adding 2. Okay? And really, that's why we study sequences, is for the power. Let me just do a little muscle here. The power of prediction. That looks like a snake, sorry. Power of prediction. Maybe I'll add a head and then you know that it's not a snake. Okay. The first sequences we're going to study today happen to have that adding element or adding common difference. So these are called arithmetic sequences. Okay? They're adding a common difference. Now you're saying, well, wait a minute, can you subtract? You sure could. Let me just go ahead and give you, actually this is lesson number 1. Let me just go ahead and give you a good example of one. Let's say we start at 13 and then we go 10, 7, 4. And we always show that it's going to go on and on forever. In looking at the elements, you might actually say, well, I want to make this into more of a list that I can just see what patterns I have here. So we might look at the element number and the actual element. So here we would list 13, 10, 7, 4. Here you tell the position. This is first, second, third, fourth. Sometimes people like to look at it that way. Now, if you look at it that way, you're already aware that you could identify a certain term number easily by not saying all the words or writing all the words. You could simply say the fourth term is 4. Or what is the first term? 13. So that's an easier way to communicate this. Now, since we've put it onto the T-chart, many of you are probably thinking, oh, we could take that and write those as points. So it'd be 1, 13, 2, 10, 3, 7, 4, 4. Now, once we have points, that brings us to sorry, I've got a cough and I forgot to grab water. That brings us to the fact that this could be represented by the independent variable and this by the dependent variable, and we could actually put it on a coordinate grid. So we would have 1, 13, 2, 10. Oh, I'm sorry, I put that at 0, 13. Wow. Let's go 1, 13, go over 1, up 13, go over 2, up 10, over 3, up 7, and I know I don't have the points there, but you can see where the numbers on my grid, which you should have. I always encourage you to. I'm just trying to give you ideas here. This is simply for an idea. Now, the first thing that I would ask off the graph, another review thing, is will this be a discrete graph or a continuous? Remember from Algebra 1 or previous math classes, discrete means they're independent points. Continuous means you'd plot the points, but then you'd put in a line. Think about what you're given. You're not given any points in between 10 and 13. So hopefully, you're looking at the discrete more than the continuous for this. Another question you might ask, is this going to be linear or nonlinear? Meaning, is it a straight line that the points form, or is it not a straight line? What I want you to explore in class with your group is when you graph these sequences, which we'll only look at the arithmetic sequences tomorrow, are they always linear or are they always nonlinear? Come to class kind of with an idea there. Now this particular one, it would be considered a decay. Why is it decay? Versus the other option would be growth. Write down right now in your notes what you think those mean and why this one is decay and the one I just showed you on arithmetic sequences at the beginning was a growth. Look back at that one. Now another way that you might choose to illustrate this is to show it visually. So let's say that we take our little dot pattern here. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need 13 more. Let's add it right here. 1, 2, 3. Okay. So there's 13. Now we're going to go down to 10. Now we're going to go down to 7. So you can see what's happening to the number of items. That might help you also in thinking about decay or growth. Remember, the whole reason we look at sequences is for the power of prediction. Power of prediction, okay? I have a monthly power bill that actually comes and it has a little graph on it to show me what my patterns have been. If I can predict what my next power bill is, it actually gives me freedom in my budget, okay? So we're looking at a sequence. We have 4 terms here, and I'm going to ask you, well, what's the 10th term? How could you find it for me? It's probably easiest to not take on my problem, but to form a simpler one. Let's look at the 5th term, okay? So in solving my problem, you're going to go back and make it simpler. That's a great technique. The 5th term, I know here I have just added a -3. Added a -3, added a -3. So if I take this 4 and I subtract 3, I get 1. There's a prediction. Now, in class, I'm not as interested in what you predict as to how you can show me. Show me the power of how you're getting that. When you get this, I don't want you to stop there. I want you to go back and write from that how you did it. So you got the 5th term by taking the 4th term and subtracting 3, and that's how you got the 5th term. Okay? Now I want to go a little bit further into your formula. How about if we say 4th term minus the common difference? Well, now that should empower you to find the 10th term. Be the ninth term minus the common difference. Now, if you actually have to do that, then you need to build up to the ninth term. When you have to build up to the ninth term, this is called a recursive formula. It's recursive because whatever term you're looking for, you're taking the preceding or the previous term, and I should put, that was a mistake, you don't subtract a common difference, you add it. If it happens to be a negative where you're subtracting, then you're adding the negative. My apologies there. So this just stands for previous term, this common difference. Okay, and that's your recursive formula. Since you watched the notes tonight, you're already empowered a little bit. I do not want to see you just come in with a memorized formula. I want you to reason how you get it because I'll be asking for that. Now, my next question is, well, I want to actually have you find the 100th term. I want a number here. I know that you could tell me from your recursive formula, well, I could find the 99th and add the common difference. However, I am telling you, I don't want that margin of error of you going 99 times. So, you need to figure out how else you could do it. I venture to tell you there is a pattern up here with formula potential. You start at the first term. How many common differences do you have to get to the fifth term? Do you say 4? Is that equal to 5 minus 1? Do you see what I'm saying here? You can find patterns all over in here. Now, don't be limited to just this or just this recursive formula. I'm going to ask you in your group to come up with a whole new formula, okay? One that you can name yourself. You can even name it after yourself in our class, okay? So, now we've discovered we can use the first term. Let's not go straight to a formula here. Let's go back and say, okay, to get my 100th term, I could use the first term and I could just take that common difference and multiply it by 100 minus 1. Okay? I hope you're beginning to see how this is related to these two. And I want you to explore that with your group a little bit more in class. So going further, let's find the 100th term. First term is 13, plus the common difference is negative 3 times 99. Negative 3 times, well, 3 times 99 is 27, 29, negative 297, plus 13. Remember, when our signs are different, we subtract. So we would say the 100th term, 97 minus 13 would be 4, 8, 2. Since the negative is farther from 0, it's negative 284. Okay? So that just gave you a lot of power to be able to find that little pattern using the first term. Okay? Power of prediction, that's what sequences are all about, guys. So now we need to look at what this formula would be that you've kind of developed here. You take whatever term you're looking for, this 100th term, for example, and what we found is that we use the first term and we add to it the difference with n minus 1. This is called an explicit formula. It always uses the first term and the common difference. It combines those two in order to use it. So when you come to class, when you're given a sequence, you'll know which is best to use. If you've got the first term and a common difference, you can find any term in that sequence. If you're given the recursive formula, or not the recursive formula, but if you're given the previous term and the common difference, then you can use the recursive formula. Now, a question for you, which term in the recursive formula has to be given to you in order to start that sequence? You can't find this term with the recursive formula. So what term is it that you can't find? Please come to class ready to answer that question. I believe this is the end of the notes for, oh no it isn't. There's one more thing that I wanted to mention. Going back to our T-chart, there is another formula that we can find, or off of the graph, if you remember graphing. If we extend going backwards one, we would have been at 16. So the 0th term, obviously it's not going to be put on there, is 16. That is also the y-intercept. You have an f of n of -3 over an n of 1. Now let's think about this on the graph terms. That's your y over your x. I'm looking for space here. Change of y over change of x. I hope you're saying that's slope. So our common difference becomes a slope in these arithmetic sequences. We could have a -3 over 1 times our n value plus our y-intercept. And there's another formula. I want you to come to class tomorrow hungry for powers of prediction. We're going to be looking at sequences. You're going to be using your group, and you're going to find other ways to find the next term, whatever term I ask you for. Look forward to seeing you tomorrow, guys.